What if the alcohol or whatever reacts with PCl3? So with PCl5 it gave us POCl3, but we can't really be expecting that from here. Nope. Because we know the P parts. That's right, CO plus. So the P part always likes to take the oxygen. I will be left with, let's write it over here, C double bond O, OH. So it grabs this oxygen over here. So that we're left with CO, and this oxygen over here makes a double bond here. Oh, this H is gone. One hydrogen is gone. And we have Cl3. What will be the best way to remove all three of these? All three of these will remove if all three of these, because when this happens, there will be one space left, and therefore one Cl can come here. So we can get a double bond O and a Cl, like we did for you. ROC double bond OCl. But now, which means two other chlorines are left. What do we do about them? Well, we could do the same thing by reacting these two other chlorines back here and again, which means we'll need 3. Which means if we have 3 here and 3 here, it simply means that 3 hydrogen protons will be given out. I use 3 because we have 3 chlorides. So the 3 chlorides will come to 3 of this carboxylic acid and give us 3 alkyl chlorides. I will be left with PO, which means PO, rather than taking 1, this PCl will each come and take oxygen form. We'll come and take P, we'll come and take 3 oxygens actually, because there are 3 alcohols, and therefore the P is 3 oxygens like automatic. And then now there are 3 hydrogen protons left, and therefore this is our product. So this hypo, so this is phosphorus acid and an alkyl chlorides. So that's it for the reagent. We've done actually quite a few, and it was really easy, a lot of cancellation and stuff. So if you want to get more about reagents and reaction condition, comment down below. I'll actually make a table which I'll link in the description to check a full large table giving all the reagents and reaction conditions. Mostly the reagents there are a lot of reagents, but quite very few reaction conditions. The most reaction conditions that exist will be like heating things like lithium aluminum hydride in dry ether, or boiling using steam. Either you heat or warm, either you reflux or you distill. These are pretty much the basic and the only ones presently at our level of reaction conditions. So this dry ether is for lithium aluminum anhydride or sodium water anhydride. Steam is from hypochlorous acid, remember the reaction, the dehydration reaction. Heat and warm is basically for the halogens. Reflux is when you want like to oxidize completely, and distill is when you want to oxidize partially. Same thing, reflux will also be when you want to reduce partially, distill when you want to reduce. Reflux will be when you want to oxidize and reduce partially, reduce completely. Sorry. Morning. While distill is to oxidize / reduce partially. So if you don't know what I mean by oxide, reduce completely or oxidize reduce partially, let's go back to here. Hydrogenation. So the reaction condition here, we're using a strong or weak. Not only when you use a strong reducing or agent like sulfuric acid, but if you do this under reflux, then you are most likely to get an alcohol. Whereas if you do this and you distill over, then you still get an aldehyde. So there are 2 ways to get aldehydes. Either you react the alcohol with a weak reducing agent, you get it, or you react with a strong reducing agent and distill over. That's why when you mix up reaction conditions, you actually get wrong answers. So this is complete reduction, this is partial reduction. So for partial reduction, if you remember cleanly, we will distill, and for complete oxidation, we will heat under reflux. So again, I'll make a table of this and link it in the description. You can download it, just follow the link in the description. And if you want any other thing, then well, comment down below. Hope you enjoyed the video. Like, share, subscribe, and see you on the next one. Buenos dias.